In this video, we'll cover the problem leftmost column with at least a 1. So here we have a row sorted binary matrix. So we know that all elements are either zeros or ones. That's why it's a binary matrix. And we know that each row is sorted in non-decreasing order. That just means that every 0 comes before every 1. So all of the zeros are on the left side of the row, and all of the 1s are on the right side of the row. We want to find the index of the column, the leftmost column specifically, that contains a 1 in it. And if it doesn't exist, we return -1. So for example, here, there are two columns, both of them contain 1s, so we want to return the leftmost, which is going to be this guy, this red one, and that has index 0 in terms of columns. Here, the only one that has a 1 is the column that's, well, I guess here in red, and that's at index 1, so we return 1. And here there are no 1s, so we just return -1. One other piece of this problem is it's not a typical matrix where we can just access whatever we want. We actually are making calls to this .get right here. So we pass in a row and a call, and it gets a value for us. There's also this dimensions here, which returns a list containing the number of rows and the number of columns in the matrix. Conceptually, what we're going to do for this problem is we are basically going to iterate over every row of this binary matrix, and we're going to do a binary search on every row. So within each row, we're going to find the kind of first column that contains a 1, and then we can kind of compare all of these answers for all of the rows and get our answer overall. So let's go ahead and see how this will work. So we'll convert this to an ES6 arrow function. Now, we'll want to know the number of rows and the number of columns we have. So I'm going to grab these from binary matrix dot dimensions here. Okay. Now we want to iterate over every row, so we'll do row equals 0, row less than num rows, row plus plus, and we'll say first call with 1 is going to be find first call with 1. We'll pass in the matrix and we'll pass in the row that we're on. Now here, whenever we find one, we want to compare against some variable and update. So we'll say left, I'll be consistent with their naming. So they did leftmost call with 1 is going to be -1. No, we're going to do infinity, because down here I want to take the min of this value. So I'm going to say this is going to equal math.min of whatever it already was, and then whatever we just found. So we kind of take the smallest, the leftmost column out of all of these. Then, there is one case where we never find any sort of 1. And so in that case, I'm going to define this so that leftmost call with 1 will be infinity. So down here, we'll say if this value is infinity, spelled infinity incorrectly, then we're going to return, we'll have a constant instead of -1, and it'll be no 1s in matrix here. So we'll create this constant, -1. And then if that condition is not the case, we're going to return our value here. So we need to define this find first call with 1 function such that if there is no answer, if there is no 1 in the current row, we should be returning infinity, so that we never actually do anything in the min operation, so that this is still infinity, and we return our constant of -1. Now we can write that function. So it's going to take in the binary matrix, and it's going to take in a row. Now, we are going to grab our last index. We'll need to grab this again, unfortunately, but we'll do num calls -1 as our last index. Or, I guess, our last call. We can name these all as calls. Last call. So we'll have our left call, which is going to be 0. Our right call is going to be last call. And then we need our answer we're going to return. So it's going to be first call with 1. And like we just said, we want the default answer to be infinity. So we're going to do something a little bit different, but we're going to set our default to be infinity. Other than this, it's going to be a pretty typical binary search from this point. So we're going to grab our mid index, or I guess mid call. It's going to be, we'll have a get mid num function that takes in 2 numbers. So left call and the right call. can write this. We've seen this many times now. Not too exciting. Left num, right num. Compute the difference between these two. Cut that in half and add it to the left num. That's what we're doing here, which is a way for us to get the midpoint between the two. And we'll return that here. Then what we'll say is mid call value is going to be binary matrix dot get. Now we know the row stays fixed, so we can just use the row from up here. And then the column is mid call, whatever that was. Now we can say if the mid call value is equal to 1, we want to do some stuff. That's one of our cases. That's kind of what the filter is, right? If that is the case, then first of all, we should update this guy and say, hey, maybe we found our answer. But we should also say search to the left of me, see if there's a better answer. So we'll say right call equals mid call minus 1. Otherwise, we have not yet found an answer, so we want to search to the right of us. So we're going to say left call equals mid call plus 1. Because we know that if there are ones, they're going to be farther to the right. So we're going to move and search to the right. In the end, we can return our first call with a 1. And I believe that should complete our logic for this question. Let's see if this works. Okay, works there. If we submit. Okay, great. Looks like it passes here. All right. Well, that's all for this video, and thank you for watching.